junior high, we're gonna have a joint meeting and just talk about the vertical alignment together and begin with the end in mind. And we're only gonna assume that 8th grade test is the end for now because we can't also ask high school math teachers to come in.
Okay.
So-
What happened to the other idea? Make them take the test.
Well, what we're gonna do is the first meeting is gonna be with the administrators.
Oh,
And
okay.
what they're gonna do is make a determination, okay, what are the needs? Once the needs have been determined and identified, then what you're gonna do is get the teachers then to have a strategy meeting where they get together. So this is the second meeting.
And you're hoping they come up with, we should
Well,
probably
that's
take the
gonna
test.
be their
Okay.
goal. They're gonna be required to sit down and duke it out. Okay,
Come up with a
how can we
plan.
support you in this, and this is what our need is, why is there a need, let's examine this, and have them really, search it out, look at it, and come up with some solutions. This is what's gonna help us most, great, but this doesn't work this way, well, it could work this way. Have them really come up with genuine solutions on how they can be supportive of middle school, how middle school can be supportive of lower level grades.
Okay, awesome. Cool.
It's not going to fix it, but it's a start.
Okay.
We're gonna take it back a little bit. I agree with her, is that at the faculty meeting, you cannot fix this,
That's true.
but you can bring awareness. And basically is at this faculty meeting.
Oh, wait. What should happen at faculty meeting if you're not fixing problems?
It's updates. Updates.
But mine's
You
ongoing.
cannot fix things in faculty meetings.
Not,
I would say that's the best place to fix them.
In-service is the best place to fix them.
Okay,
embedded daily professional development is the best way to fix them.
Oh,
In
wow.
department planning, in conversations, in walkthroughs.
okay, keep going.
Okay,
Go ahead.
so what we would say is at this faculty meeting, you need to bring the resources that you use to help you do vertical alignment, to do your lesson plans. Because from that, when you see your teachers bring what they bring, then you're really assessing is that, hey, do you realize that my teachers, and this is what I'm talking experience, don't even know what's on the star. And if you don't know what's on the star, how can you be planning effectively? Or if you don't know your TEKS, okay? So I think right there in itself says that, hey, maybe some teachers, hey, I have the resources, but then other people say, hey, yeah, I'm really just taking this trip, and I don't even have the right math.
Well, and if you think about the elementary math teachers, how many of you are departmentalized in elementary, 4th and 5th grade? And you only have one math teacher, that person plans all alone. They are the end-all be-all if they don't have a partner or somebody to pair up with, and just to hear what other people see, what other resources people have. That's what training is doing, like giving science teachers and math teachers, hey, these are some good books for them to use. And then all of a sudden somebody says, oh my gosh, I need to get that book, that's awesome.
Yes, okay, cool. So you would have them bring the resources and evaluate what they're actually using.
I think
Okay, how about y'all?
We've come up with, as we're talking, I think a more effective way would be taking a strand, I'm thinking of my own campus here. Taking a strand, probability and statistics is very low on my campus. Taking that strand and going, okay, here's, pulling it out, scaffolding it, and talking about what are you doing in that faculty meeting. This is, of course, just a start. 5th grade, what are you doing? 1st grade, how do you start it? And then having them talk about it, model it, and then come back again and revisit. But I think it's taking each strand, because showing that this is a weakness on our campus for our students. Is it really students, or is it the teacher's ability to teach that strand?
Okay, so certainly taking everything all at once in a faculty meeting won't work. So reduce it down to something that's manageable, one strand. Let's look at this one thing. Okay, how about y'all? Okay, all y'all.
All y'all, that's unique to Texas first. We kind of brainstormed, and we were gonna invite the middle school to our staff development meeting, because we don't have faculty meetings, we do all of that email.
Okay.
And online, every time we get together.
So it's always
a
the staff development
Yes,
meeting.
that's staff
Cool.
development. So, and then each grade level is responsible for bringing one food item. And they have to keep track of what the quantity is that they brought, how much it cost, and the total, all that kind of stuff. So then we'll gather the data for that as we're eating and chatting, and then we'll sit in vertical teams. Like you can put that together, organized, so they can know which table to sit at, and then you do the get to know each other, that kind of stuff. Then you go through and you collect your data and you look at it, and then you, in the vertical team, then you look at, okay, what TEKS are taught at kindergarten with what we just did, what TEKS are taught at first grade, second grade, third grade, what happened in seventh grade that kindergarten is doing as well, so that they get a chance to see it. Then, with just that one little piece of the activity, then you see what TEK that was, and then, okay, let's look at now, where are the other places that we need to pay attention to?
Okay, hang on, I'm getting confused. So they bring in a food item, what does that have to do with TEKS?
Well, because they're gonna do the quantification, if it's math, that's one of the things they can look at, but if it's also nutritious food, then that's some of the health stuff. They're gonna talk about, okay, what TEKS are involved in what we
With
just
the
did.
food,
Yes.
okay, got it,
Yes.
okay.
So then they'll look at that and figure out, oh, well, what Mrs. Smith does in kindergarten makes a difference with what seventh grade does too.
Okay.
And then you plan your schedule about how you're gonna continue the discussions and activities that go with it, but,
It's gotta be an ongoing fix, it's not, one meeting's not
Right.
gonna, because you're gonna have more than one area that's gonna need attention.
But one of the
Break
things
that
that
in.
I see happening there is some modeling going on. Let's do something concrete and add the abstract to it. Cool. Okay, awesome. We were supposed to have looked at page 211 to 213. I'm gonna let you look at that. It's in your binders. It's a science lesson about whales and there's several other things. And we could have done a little bit more comparison there. But we're running behind schedule, so we're gonna hurry up here. Okay, in this big book,
Ben, could I say one thing about the TEKS?
sure.
They're in science very misunderstood. Teachers misinterpret them. That's why they need to go to the national standards that Jim was talking about. For example, the sixth grade has the basis for the periodic table, but you do not teach a periodic table until the eighth grade in the TEKS.
Can you say that one more time?
For teachers to understand the science TEKS, because they're written in short phrases, they must go to the national standards, which explains the age appropriateness for the concepts, so the teachers will better understand what the TEKS mean and they don't misinterpret. And the example that I gave, that in sixth grade, it's the foundation for understanding chemicals like the geology tests of luster and all of those. That's in sixth grade. And it sets the stage, elements and compounds, sets the stage then for the eighth grade for them to understand this very complex summary, which is a periodic table. So they do not teach a periodic table sixth grade.
I think, about a decade ago, it was something like only 10% of their teachers know their content area. And it's not that they didn't know the knowledge, but they didn't know when to teach it.
Or they go way too far or not far
So we
enough.
have third grade teachers teaching sixth grade material and vice versa. It's
Well,
just
look at what my
scary.
kids are doing, they're doing sixth grade math. Well,
Yeah, I have a
the
great
third grade
story
math
for
that you're
that,
supposed to be
too.
teaching. Can they do that?
Okay, yeah,
It's
we can bring up all sorts of anecdotes, and, right here, this book right here, in 2007, so, what is that? 2, 3, 5 years ago, 6 years ago?
Is that the inquiry one?
Okay,
That's the
7 years
Oh,
ago,
the Van der Waal.
this is what they're saying. And I can attest they were saying this a long time before that.
1800s.
But you teachers, and this is what you need to look for, you need to help your teachers to, rather than have a classroom of a collection of individual students all learning math processes, to have a classroom as a math community. Let's learn this together. Let's figure out the answer together. Teacher is the sole authority versus verifying with logic and math and evidence. The teacher can be wrong, the teacher can present a hypothesis in math, and students can verify it. Is it right or is it wrong? Memorizing procedures to capturing mathematical reasoning, Mechanics of finding the right answer, we talked about that. For conjecturing, inventing, and problem solving. And math is a body of isolated concepts versus math is connecting all of the processes of math into one big whole. So that's what this book, that's what they are saying.
But see, people don't wanna do this route. It's faster to do this route, just get to the point, let's not, cause this takes too much time.
Well, most books are written here, certainly. That's where the books are.
It's also math, of all the disciplines, is still that institutionalized instruction that has been happening when you're in the factory model of education. Reading is sort of getting away from it, science has always been, I think, labs or whatever are supposed to have been labs and whatnot. But math has always been institutionalized, and if you look at your math teachers are good mathematicians. I was not a good mathematician, so I understood the need to
They
explain.
become math teachers because they like it.
Yes, and they do the 3 examples. I mean, my whole career was the 3 examples, then sit down at their desk, sit at your desk and work the problems in the book. And the teachers teach the way it was modeled for them. So I'm not sure that they don't want to do it this way. I just think it's a shift for them in everything that they've ever experienced in their own math life.
Okay, I forget the guy who, I think it's Pullum, who presents this, but it's called The Idea of Force Fields. And the way it works is that teachers like to see equilibrium. They like to see the status quo. And so if you want them to change, then you're gonna have to change part of that status quo and make them uncomfortable. Make them uncomfortable enough to change. And there's 2 ways you can do that. You can push them from one side, or you can pull them. And in terms of constant pressure, this needs to be the push. Every lesson, every time isn't gonna always be that way. But in your faculty meetings, in your staff development meetings, this is the push. And interestingly enough, all of this works for all the other classes too, not just math and science. But.
Yeah, I just need some clarity with number 1. I think I understand, but I'm not sure if I fully. Can you kind of give some clarity on collection of individuals? What does that mean?
Just a classroom of kids, a classroom.
Each student is isolated and doing their own thing. And here, do this problem, and they're all doing the same problem individually.
Okay.
5 word sheets.
Okay.
Which happens a lot, and sometimes needs to happen. But then, there's times when the whole class needs to work on a problem, together, put their brains together on the same problem and figure it out. Or small groups of class. And this is part of a culture thing too, and teacher has to create a learning environment, a culture that says we're all in this together. You need help, I'll help you. And student to student. Okay, going on. Okay, and this is a little tongue-in-cheek way to look at things, but not. You may agree with this or not, but this I was thinking, well, what? How is a math or science teacher different from a regular teacher? If you look, all of these things on the left are great things. They're good things. Do we expect more out of math and science teachers? Talk to your double partner about that. Do we expect more? We expect this out of all of our teachers. Do we expect more out of math and science teachers?
Use the levels of questions.
I think every content is going to have their own discovery. They may not be exactly right.
Well,
That's how it's-
yeah, come on.
Investigation. Anybody else to create an investigation?
the expectation. You know,
Okay, raise your hands. Did you come to agreement in your elbow partner pairs? If you and your partner agree that we do expect more out of math and science teachers, raise your hand. Okay, we have 3, 4, and everybody else against.
It's a different set of expectations. What we're talking about with this is, we talk about math and science, and we talk about the world, and we talked about bringing order to it, all of that today. We expect the math and science teacher to bring the world, the real world, into the classroom through a created activity. You know, if you're looking at English or social studies, you can rely a lot on imagination. You've got the materials in front of you, they're pretty handy. So the expectation in terms of these type of activities, the inquiry and the bringing the work, that part is a different expectation than teachers have been, than has been required of them, I think. That part of it's different and more demanding than to,
Okay,
when
so
you
why
say,
didn't you raise your hand?
well, I guess.
Cause we're
it's a
saying that
difference
it's
in-
not there yet.
Yeah.
It's not there, it should be.
So right now, you don't expect more,
We don't.
Right.
but you should.
We should, yeah.
But we want
I think we always
more.
have in science.
But if you look at
She was
science
Not
labs,
so much in math. Math was more stand and deliver. Science, we've always had to do labs, bring in specimens, all
Right.
these
But what should
activities.
Kind of more
And now we're
expected.
we're grabbing the math people and, hey, y'all need to come do some of this with us because it's great for learning.
Mhm. Yeah.
I mean, that's my perspective on being in the classroom all these years.
but why shouldn't our math classes be called math labs?
Is that-
With the concept that we're going to now, it's like, as Dr. West says, is now the math classes need to have space to have it, I mean, it's,
Well,
Yeah,
if
well,
we
you know,
expect
and
more,
on the
we'll
college
start
level,
calling
what is a math lab? It's tutoring on the process. It's really not a math lab, it's a math tutoring session. But, yeah, that'd be great. Okay, good to think about.
I
Okay,
think teaching
tell me
science
what-
is twice as hard because we have all of the labs, setups, takedowns, it's a lot more work.
Yeah, it requires some advanced planning. Okay, so what is higher order thinking? Huts. Talk to your elbow partners. Define, come up